The second part of the problem 21. In the given figure, V23, which is equal to 4V1, n moles of the diatomic ideal gas are taken through the cycle with the molecules rotating but not oscillating. So now we are going to solve 4 parts, that means 4 subdivision. So this time what we are going to do, we are going to consider the path from point 1 to 2. So we are going to find the answer for these 4 questions for the path 1 and 2 only. Clear? So anyhow, let's rewrite the given one more time. So this is the diatomic gas molecule. So this is the diatomic gas molecule. So for diatomic gas molecule, CV value is 5 over 2 times of R and CP value is 7 over 2 times of R. So by using this, we can find the value for gamma, which is CP over CV. So 7 over 2 times of R over 5 over 2 times of R. So we can cancel this R and the number 2. So by that we will get gamma, which is equal to 7 over 5, which is equal to 1 over 4. So we are going to use this value wherever we need. Clear? So let's see the figure one more time. So this time what we are going to do, we are going to consider the path 1 and 2. That means the path 1 and 2 refers to the isothermal. So now for this isothermal part, we have to answer for question number D, E, F and G. Clear? So okay, let's start. So in the first part, we are going to find the answer for work over, that means W over N or T1. So I can write the question first. So this is part D. Part D. We are going to consider path 1 to 2. So this path 1 and 2 refers to isothermal. Isothermal means temperature constant. So in part D, what we are going to do, we have to find the answer for W over N or T1. We are going to find this answer. So you can see here, if you want to find the answer here, first of all, we have to write the formula for work done for the isothermal condition. So in the theory, we already studied the formula for the work done for the isothermal, which is given by the formula W, which is equal to N R T natural log of V final over V initial. So that means V final is nothing but V2. That means we are going to consider point 1 and 2. That means the volume at point 2 and the volume at point 1. So anyhow, I can just go back to the diagram here. You can see we are going to find the point 1 and 2. That means volume at point 2 and volume at point 1 we have to write. So that means we have to use this formula. Now let's rewrite the formula here. So I have to write W, which is equal to, so that means W equal to N or T natural log of V final, that means V2 over V1. Why V2 over V1? Because we are going to consider point 1 and 2. So that means the final point is 2, the initial point is 1. So volume at point 2 and over volume at point 1. Now we have to find W over N or T1. So we have to consider one, because the temperature is constant. So whether T1 which is equal to T2 or T2 which is equal to T1. So let's we take T1. So now what I'm going to do, I can write T1 here. Now I can move this to the left hand side. By that we can write this as W over N or T1, which is equal to log of what is V2? V1, which is 1, and V2 and 3, which is equal to 4 times of V1. We already used this value. So that means volume at 2 is 4 times of V1, which is 4, right? Over, and volume at V1 is 1. So we have natural log of 4 over 1. So here I got the answer W over N or T1, which is equal to 1.386. So we can round this number to W over N or T1, which is equal to 1.39. So this is the answer for part D. Now we have to go for E part. What is E? I have to see. E part, we are going to find the Q over N or T1. So I have to write the question first. In part E, we are going to find Q over N or T1. And again, we have to consider the path 1 to 2. So this is isothermal, right? Isothermal. So in isothermal, let's rewrite the first law of thermodynamics. Q, which is equal to change in internal energy plus work done, right? So in isothermal, your internal energy, which is equal to 0. So that means we will get Q over Q, which is equal to W. So now for this W, what I am going to do, let's we take the answer, because in the previous part also we find the answer for this from point 1 to 2, right? Path 1 and 2 we find. So what I'm going to do, in place of work done, what I'm going to do, I can take this value and substitute here. So if you want to substitute here, you have to write this number in terms of W. So if you write this W, how can we write? W, which is equal to 1.39, right? Multiplied by N R T1. Am I right? So if you rearrange this equation, we can write. So in this place of W, I'm going to substitute this number. So let's substitute the value. So Q, which is equal to 1.39 N R T1. So we can bring this here. By that we will get this question, right? So what I'm going to do, I can move this term to the left hand side of the denominator. Therefore, Q over N R T1, which is equal to again 1.39. So this is the answer for part E. Clear? Because in part D also we find the answer for work done for the isothermal. In part E also the same isothermal curve. So we can take the answer from the previous part. Clear? Okay. Now we have to come for part F. What is the question in part F? Let's write. In part F, they ask you to find change in internal energy over T1. We have to find. Again for path 1 and 2. This path is for isothermal, right? Isothermal means, what's the condition? Change in internal energy which is equal to 0. So that means we don't need to substitute anything, because here we are going to find this answer. So that means if your internal energy is 0, your change in internal energy over N or T1, which is equal to 0, right? Because your isothermal internal is 0. So the answer, we cannot able to get anything, because here we have to find this answer for internal energy. Your internal energy equal to 0 for isothermal curve. So the answer for F part is equal to 0, right? Now we have to come for the last part, which is G. What is given here? They ask you to find change in entropy over NR. We have to find for this again for path 1 to 2. So in this question, we are going to focus only for the path 1 and 2. So what is the path 1 and 2? Which is again isothermal, right? So here for the change in internal entropy, change in entropy, what we studied, change in entropy is equal to N or natural log of V2 over V1. So this is the condition for isothermal. Clear? This is the condition for isothermal. Clear? Now, point 1 and 2 means V2 over V1. Clear? So I have to use this one. So we can do one thing. If you take this equation for getting this answer, we can bring this to the left hand side of this denominator, because this is the general, this is the main formula for isothermal for entropy change. So if you move this to the left hand side of the denominator, we can write delta S over NR, which is equal to natural log of V2 over V1. Again V1, which is equal to 1, V2, which is equal to 4 times of V1. Clear? So if you substitute, what you will get? Change in entropy over NR, which is equal to natural log of 4 over 1. So here, natural log of 4, I got the answer delta S over NR, which is equal to 1.39. So this is the answer for the last part. That's it. Thank you. So here we got the answer for 4 parts. So I will show the question. because I told you already this question has 15 sub questions. So in the first part of the video, I solved 3 questions. Now we solve 4 questions from path 1 to 2. Again, we have one more path, which is 2 to 3. And then the last part is 3 to 1. So 2 more videos for the same question. Clear? So please see the continuation. If you want to know the continuation for the previous 3, as well as the next part of the questions, you have to see part 1, part 2, part 3, part 4. So this question is the part 2 of the question 21. Clear? So that's it. Thank you.